Okay, so today we are going to talk about chapter 11, ratio, proportion, and rate. So let's get started. Okay, so this is the 11th chapter. And we have to talk about ratio, proportion, and rate. But since today I'll just talk about ratio and proportion. Okay, so this is what we'll talk about this today. Right. So let's start our discussion with a formal definition and then I'll explain this. So we can say that a ratio is a comparison of two values expressed as a quotient. Okay. Now, the definition says a ratio is a comparison of two values expressed as a quotient. What are they exactly trying to say? For example, if there's a class which has, let's say, in total 30 students, and we want to know the ratio of girls to boys, and we have been told that out of those 30 students, 12 are girls and obviously if we have to 30 to 12 girls and to 18 would be boys, right? And we want to know the ratio of girls to boys. Now that is very simple. Ratio of girls to boys can be written as 12 ratio 18. I can also write it this way, 12 ratio 18. Both these are correct, right? And they are equivalent. So in short, ratio is just used for comparing, right? For comparison. I can always just simplify these two. This is 6 and then this is 9 and then again this is 2 and this is 3. So the final answer would be 2 ratio 3, right? So the ratio of girls to boys is 2 ratio 3. Okay, so this is a basic idea about what ratio is. Obviously, we'll talk about proper examples. Let's talk about proportion. Uh, Proportion is an equation. Okay, a proportion is an equation stating that two ratios are equal. Okay. Now, a proportion is an equation. When we talk about proportion, we have an equality sign and we will be having two ratios here, right? For example, if we know that there's a class of 30 students, out of which 12 are girls and 18 are boys. And other than this, if we say that each student carries two pencils, for example, okay? If each student carries two pencils, then we have been told that if we talk about girls, so two girls would have four pencils. And we are interested in finding out the number of pencils with boys. How do? We will just equate ratios, okay? So we know that it is 2 ratio 3 and it would be 4 ratio x. We need to find this x. How do we find this x? by cross multiplication. This will give us 2x equals 12, that is x equals 6. Now I repeat, okay? In these questions, we will be using proportion because we would be interested in finding out these x. Forget about if you did not understand the context, just know that we have two ratios, okay? One is 2:3 and the other one is 4 ratio something. I need to find that something. I know that this quantity is 4 for girls and I am interested in finding out the quantity for boys, okay? So this is how I do. I make a proportion by equating two ratios. I am interested in finding out x. Obviously, I need to make x the subject. And by cross multiplying, by multiplying x with 2 and 3 with 4, I will get this, and x equals 6. So I got that x is 6, that boys will have 6 pencils. So did you understand this? Anything that you did not understand so far?
No, it's clear.
Okay. All right. Now, since we had a discussion about proportion, let's just um, continue this. Let's talk about two types of proportions. Now, here I will talk about proportion. We have two types. One is directly proportional, and the other one is inversely proportional. I'll give you an idea this way. For example, if we talk about eating and weight, okay? Now I know that the more I will eat, the more weight I will gain, right? This, they are directly proportional because if I will eat less, my weight will be less. If I eat more, my weight would be more, right? So this means that these two quantities are directly proportional, right? And eating is an independent quantity. My weight depends on eating, but eating itself is an independent quantity. So independent quantity should be x and the dependent quantity should be y. Since if I will eat more, my weight would be more. This means that y is directly proportional to x. Okay, let's talk about exercising and weight. If I exercise more, my weight would be less, right? I'm just giving you an example, okay? So if I exercise more, my weight would be less. If I exercise less, my weight would be more. And again, weight is depending on exercising. So weight would be y and exercising would be x. This time, y is inversely proportional to x, okay? So this is why we have two types of proportions, because it is not necessary if I increase one quantity, the other would increase. It could be that the other quantity decreases, right? Did you understand this?
Yes.
Okay. So when we have y directly proportional to x, when I remove this proportionality sign, I get y equals kx. And again, when I remove this proportionality sign, I will just introduce a constant. And this is what I'm going to get, okay? And if I talk about their graphs, so for direct proportion, this is what I'm going to get. And for inversely proportional, I will get this. This is y and this is x. Now look, when I am exercising more, my weight will reduce, right? When I am exercising more, my weight will reduce. When I will exercise more, my weight will be less. When I exercise less, my weight would be more. Did you understand this through the graph as well?
Yes.
Okay, perfect. Now, we are done with this thing. Okay, so let's talk about some examples. Okay, let me just take out the examples which I prepared. Okay, so I'll clear the screen and let's talk about some examples. Okay, so this is example number 1. Simon made a scale model of a car on a scale of 1 to 12.5. Okay, now let's understand the question. Simon made a scale model of a car, right? So we know that cars are very, very big, okay? But Simon made a small version, a model version of that car. And the difference is that if a dimension on the car is 12.5, that dimension on the model would be 1, right? उसने 12.5 times छोटा model बनाया, obviously because models are small. ठीक है? Okay, let's complete the question. The height of the model car is 10 centimeters. Okay, the height of the model car is 10 centimeters. Part A is work out the height of the real car. Work out the height of the real car. Okay, now let's talk about the solution. Okay, we have been told that the ratio or the scale for model to real car is 1 ratio 12.5. Okay, and we know that the height of model car is 10 centimeters. The height of model car is 10 centimeters and we are interested in finding out the height of real car. So I need to write down x here. Again, we will make our proportion by equating these two ratios. 1 by 12.5 equals 10 by x. I have to cross multiply and this will give me x equals 125 centimeters, right? And then obviously when we will talk about the units and everything in that section, I'll tell you that it's better to convert the answer in meters, but since you were already given the measurement in centimeters, it is completely fine to leave it this way. Anything that you have not understood?
No, it's clear.
Okay, very well done. Let's talk about the second part. This is the second part. The length of real car is 500 centimeters. Work out the length of model car. Now, obviously, again, we have to refer to the scale 1 ratio 12.5. This time we have the length of real car. So it is 500 ratio, and we will have X here because we have to find the length of the model car. This is for model and this is for real. Again, we need to make our proportion by equating both these. This equals X by 500. I will cross multiply. 500 equals 12.5x, and this will give me x equals 40 centimeters, right? Did you understand this?
Yes, I did.
Okay, very well done. Let's talk about another question. So, Alex and James divided 40 pounds in the ratio 3 ratio 5. How much do they each get? Okay. Alex and James divided 40 pounds in the ratio 3 ratio 5. How much do they each get? Okay, so do you have any idea about this question?
Yes, I guess we would add the ratio like 3 plus 5, and then
Very well done.
40 divided by 3 plus 5, and whatever the answer is, we will multiply it with James and Alex's ratio.
Excellent. Okay. So again, this ratio is just telling us the share of Alex and the share of James. And this is what they had in total. Okay. So in order to find this, let's do it this way. So 3 plus 5 will give me 8. And this is basically telling me that I can find for Alex this way 8 ratio 3. Obviously, we have thousands of methods of doing this question, but this is how I am used to doing this. So 40 ratio x, this x will give me the share of Lx, right? Because 3 is for Lx. And I will make the proportion by equating these ratios. 8x equals 40 in multiplied by 3. And I am going to get x equals 40 by 8, that is 5 multiplied by 3, this is 15. Now you know that this would be Lx share, so you can just subtract this from 40, or you can find this, or you can find James share separately. So method 1 could be that again you do it this way, 8 ratio 5, 40 ratio x, make your proportion, cross multiply, x will give you 25, right? And method 2 would be, this was the total amount, subtract the amount you got for Lx, and you will get the same amount for James. Okay, so did you understand these two methods?
Yes.
Okay, perfect. All right, so just give me 1 second. Okay, so let's talk about some past paper questions. So let's say the question is, at this time, the water temperature inside a kettle was 25 degrees. The kettle was heated and the temperature of water inside increased at a steady rate to 95 degrees at 0914 hour. Okay, calculate part 1, the rate of increase of water temperature. Okay, this is the first part. We'll talk about the first part first and then we'll talk about the second part. Okay, although I agree that we have not discussed rate right now, but still we can do this question. Okay, because rate is not that different, it is a very basic concept. So you'll get a better idea about rate with this concept, with this question. Okay, so the question is, at 9 hour, think about this as 9 a.m. ठीक है, सुबह के 9 बजे the water temperature inside a kettle was 25 degrees. ठीक है, initially kettle बंद है and the temperature of water was 25 degrees. The kettle was heated and the temperature of water inside the kettle increased at a steady rate to 95 degrees at 9:14 a.m. ठीक है, this means that from 9 a.m. This means that from 9 a.m. to 9:14 a.m. in these 14 minutes, what has happened? The water temperature has increased from 25 degrees to 95 degrees, right? From 25 degrees to 95 degrees, and this is an increase of 70 degrees. Abhi, I did not read what I had to find. Abhi, I am just discussing what we have been told. Okay, calculate the rate of increase of water temperature. Rate means change in any quantity with time. Okay, change in any quantity with time. So यहाँ पे if we're talking about change, what change would it be? The change in temperature and with time. So since rate is change in a quantity, it could be anything. Okay, change in a quantity divided by change in time. Okay, so change in quantity 95 degrees हो गया था from 25 degrees, that is 70, and change in time 9 a.m. to 9:14 a.m. होगा था change, तो change was of 14 minutes. Okay. Now the answer is 5 degrees per minute. This means that after every minute, the temperature was increasing by 5 degrees. Okay. Did you understand this?
Yes, I understood.
Very good. Okay. So let's talk about the second part. We got the answer for the first part. I'll just write that down. It is 5 degrees per minute. Okay, and the second part is the temperature of water at 0910 hour. Now we are interested in finding out the temperature. You can say at 9:10 a.m. Okay, at 09:10 a.m. Okay, so how are we gonna do this? Can you tell me? Any idea?
This time the temperature difference, sorry, the time difference would be 10 and the
Very
temperature
good.
difference would be same.
Okay, so can you tell me the answer, please? Whatever you're saying, I did not understand it. Just tell me the answer. And even if the answer is wrong, I won't mind that. You know this, okay? Just tell me whatever you are getting.
Okay, just wait.
Okay, sure.
I got 3.5.
Okay, okay. All right. Not bad. But look, what is the question? The temperature of water at 9:10. This means that at 9 a.m. the temperature was 25 degrees. Okay. And after 10 minutes, what would be the temperature? We need to find that. And we know that after every 1 minute, the temperature is increasing by 5 degrees. Okay. So I'll tell you. We have to start from 9 a.m. and come to 9:10 a.m. We have 10 minutes, and we know that each minute the temperature is increasing by 5 degrees. So in 10 minutes, the temperature will increase by 10 multiplied by 5, that is 50 degrees. Okay. And initially, the temperature was 25 degrees. So यहाँ पे it was 25 degrees. During these 10 minutes, it increased by 50 degrees, and now it would be 50 degrees plus 25 degrees equals 75 degrees. This is the answer. Okay, you were not asked to find out the rate. No, you were asked to find the temperature at this point. Initially, it was 25, and after 10 minutes, the temperature would be 25 plus this figure. And this figure is telling you that in 10 minutes the temperature would increase by 50 degrees, and this was the initial amount, so obviously you need to add this. Okay, so did you understand this?
Yes, now I did.
Okay, perfect. Now let's talk about another question. So let's say we have a map of Singapore has a scale of 1 ratio 60,000 and 500. Part A. A string is used to measure the distance along MRT line between Bedok station and City Hall station. Okay, and it was found to be approximately 16. It was 16 centimeters. What is the actual distance in kilometers? Okay. A map of Singapore has a scale of 1:60,000 and 500. This means that if there's a dimension in reality that is 60,000 and 500 centimeters, meters, kilometers long, actually it would be just 1 centimeter, 1 meter, or 1 kilometer. Okay. Map पे it would be 1 centimeter if it actually is 60,000 and 500 centimeters. A string is used to measure the distance along MRT line between two stations. This is a station and this is another station, and on map the distance is 16 centimeters. The question is, what is the actual distance in kilometers? Okay. So this question has two parts. First, we need to find out the distance in centimeters because this is in centimeters, and then we'll convert it to kilometers. So can you tell me how to find this?
First, we will write 1:60,500, and then under the map we will write 16 centimeter, and we'll solve it with the ratio method.
Okay, so you are saying that we will basically use proportion, right? This is one
Yes.
ratio and the other ratio would be 16 ratio x, right? And then I have to cross multiply. Very well done. So x is what? What are you getting for x? 16 multiplied by 60,500.
96,968,000.
Okay, very well done. Okay, and this is in centimeters. We want to find the answer in kilometers. So we know that. What do we know? We know 1 kilometer equals 1000 meters. And how many centimeters? 10000, right? Do you agree with this?
Yes.
Okay. And now if I have this, if I have 968,000 centimeters and I'm interested in finding out it in kilometers, I have to divide this value by 1 and 5 zeros. So I will get 9.68 kilometers as my answer. Do you agree?
Yes.
Okay, perfect. Now let's talk about the second part of this question. Let's say we have the second part as if the land area is 10.2 kilometers square, what will be the area in map? What will be the area in map? Okay, now actually there's some area that is 10.2 kilometers and they want you to find the area in map. Okay, so how to do this? Okay, now solution. Okay, what is your idea? What do you think? How are we going to solve this question?
I think we will solve it again by the ratio method, but this time we will first convert the kilometer square into centimeter square.
Okay, ठीक है. We can do that first. So you are saying that I need to convert 10.2 kilometer. Okay, and then I will apply the ratio directly.
I guess.
Okay, very good, very good. But I'll tell you. Look, we know that 1 centimeter और किलोमीटर और मीटर, बिकॉज यहाँ पे हमें उन्होंने सेंटीमीटर मीटर कोई यूनिट नहीं बताया, ठीक है, बट लेट्स टॉक अबाउट इट इन सेंटीमीटर्स. 1 centimeter रेशियो 60,500 centimeters actually, ठीक है. Let's convert this to kilometers maybe, ठीक है. I can write down that 1 centimeter on my map ratio 0.605 kilometers. But you have to be careful. We are interested in finding out the area that has the units kilometer square. Okay, so we cannot use this ratio directly. We need to square both sides just so we get a proportion, just so we get a ratio for kilometer square. So if I square both sides, I am going to get 1 ratio 0.605 square. That would be 0. Let me just write the value down. Just give me 1 second. Let's find it first. 0.605 square. Okay. So this has turned out to be 0.366 kilometer square. And this is in centimeters. So if the land area is 10.2 kilometers square, 10.2 kilometers square, what would be the area on map? That would be in centimeters square. I will cross multiply. 10.2 equals 0.366 x. Can you tell me the value of x? The value of x is 28 centimeters. Now I will explain this again. Don't worry. Okay, look. In this question, our scale was for centimeters, right? And the second part is about area and the units are kilometers square. You cannot use this ratio directly in order to find the area of map. First, you need to have a scale for area. Okay? So you have to convert this to a scale of area by squaring both sides. Okay? So 1 centimeter square will become 1 centimeter square, and you will multiply 0.605 into 0.605 and you will get this. Now you can use the scale directly to find the area on map representing this area actually. Did you understand?
Why did we centimeter squared ले सकते थे? मतलब सेंटीमीटर स्क्वायर को हमने किलोमीटर स्क्वायर में क्यों नहीं कन्वर्ट किया?
Is इनको?
Like the one जो आपने लिखा है.
Exactly. You can do that. You cannot do that. It is completely your choice. ठीक है? It is completely, I did not do this because I knew कि जब मैं 1 centimeter को kilometer में convert करूंगी, that will become a 0.0000 type वाला number, and जब मैं उसको square करूंगी, that will become a very very big number, मतलब decimals वाला, ठीक है? So I did not do that intentionally. It is completely fine. It is not incorrect. I know that कि on map 1 centimeter square is actually 0.605 kilometer square. It is mathematically correct. ठीक है? इससे कोई फर्क नहीं पड़ता कि ये सेंटीमीटर में है एंड देन ये किलोमीटर में. That is completely fine. And you could have converted this in kilometers too, but then आपका ये आंसर 0.000 बहुत 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 इस तरह का होता. इसीलिए I did not do this intentionally. It is completely your choice. You can do that as well. The answer would be correct. Although the answer would be in kilometer squares, but that would be correct, right?
Okay.
Any other questions?
Oh no.
Okay, so I'll end the meeting, okay? Take care.